Okay, so fast facts for structure and function. Fast facts for structure and function. Most of the cardiac muscle of the heart is found in the myocardium. So we're just doing fast facts. Most of the cardiac muscle of the heart is found in the myocardium. Blood returning to the heart from the body organs enters the right atrium through the vena cava. The only vein in the body that transports oxygen-rich blood is the pulmonary vein. The semilunar valves prevent blood from flowing backwards into the ventricles. The term vasoconstriction refers to decreasing the size of the lumen of the blood vessel. Which of the following represents the flow of blood from the heart to the body organs and back to the heart? Arteries to capillaries to veins. Which of the following represents the flow of blood from the heart to the body organs and back to the heart? Which of the following represents the flow of blood from the heart to the body organs and back to the heart? Arteries to capillaries to veins. Which of the following applies to the sinoatrial node? It generates autorhythmic impulses to contract the heart. The superior vena cava enters the right atrium of the heart. It's important to note that the superior and inferior vena cava return the oxygenated blood from the upper and lower body halves to the right atrium. The mitral valve, so mitral valve prolapse, is a condition which causes blood to backflow into the left atrium. The mitral valve or mitral valve prolapse is a condition which causes blood to backflow into the left atrium. The normal function of the mitral or bicuspid valve is to prevent backflow of blood into the left atrium from the left ventricle. The pulmonary semilunar valve prevents backflow of blood into the right ventricle. The pulmonary semilunar valve prevents backflow of blood into the right ventricle. The pulmonary semilunar valve prevents backflow of blood into the right ventricle. In order to promote a forward flow, the pulmonary semilunar valve blocks the backflow of blood into the right ventricle and allows it to progress through the pulmonary arteries. In order to promote a forward flow, the pulmonary semilunar valve blocks the backflow of blood into the right ventricle and allows it to progress through the pulmonary arteries. Which of the following contains blood with a relatively high oxygen content? The left ventricle. The left ventricle receives the blood which has been oxygenated in the lungs via the left atrium. Which of the following contains blood with a relatively low oxygen content? Which of the following contains blood with a relatively low oxygen content? It's the pulmonary artery. The pulmonary artery travels from the heart towards the lung to obtain oxygen. The four pulmonary veins return oxygenated blood to the heart. Which term indicates that tissue in the heart has died? Infarction. A myocardial infarction or heart attack occurs from lack of oxygen because of a restricted blood flow or ischemia. Which term refers to the severe chest pain evident during an attack of myocardial ischemia? Which term refers to the severe chest pain evident during an attack of myocardial ischemia? Angina. So angina is severe pain and is used to refer to angina pectoris or referred pain that occurs whenever the heart has insufficient oxygen. About 70% of the atrial blood flows into the ventricles before the atria contract. About 70% of the atrial blood flows into the ventricles before the atria contract. About 70% of the blood from the atria has already entered the ventricles before the atria contract to propel the 30% remaining. The atria will empty during atrial systole. The atria will empty during atrial systole. During the contraction phase of the atria, or atrial systole, The pressure is sufficient to propel the remaining blood out of the atrial chambers. The chambers fill during relaxation or diastole. During the contraction phase of the atria or atrial systole, the pressure is sufficient to propel the remaining blood out of the atrial chambers. The chambers fill during relaxation or diastole. The first heart sound results when the atrioventricular valves close. The first heart sound results when the atrioventricular valves close. The force of the atrioventricular valve stopping shut produces the first heart sound or lub. The second sound is from the closure of the semilunar valves. Which chamber of the heart contains the pacemaker? Which chamber of the heart contains the pacemaker? The right atrium. The sinoatrial node or pacemaker is an area of specialized cells in the right atrial wall that initiate the cardiac cycle. The sinoatrial node or pacemaker is an area of specialized cells in the right atrial wall that initiate the cardiac cycle. Which area allows the atria to completely empty as the ventricles fill with blood? The AV node, so the atrioventricular node. Which area allows the atria to completely empty as the ventricles fill with blood? The atrioventricular node. The atrioventricular node has junctional fibers which will slightly delay the passage of the impulse, allowing the ventricles sufficient filling time. The atrioventricular node has junctional fibers which will slightly delay the passage of the impulse, allowing the ventricles sufficient filling time. The highest pressure exerted by the heart is called the systolic pressure. The highest pressure exerted by the heart is called the systolic pressure. The systolic pressure occurs while the ventricles contract, while the diastolic or lowest pressure is during relaxation. The pulse pressure is the difference between them. So the difference between the systolic and the diastolic pressures, respectively. The difference between the systolic and diastolic pressure is the pulse pressure. So the difference between the systolic and the diastolic pressure is the pulse pressure. The average blood pressure in an artery is the mean arterial pressure. The average blood pressure in an artery is the mean arterial pressure. The mean arterial pressure is an estimate of the average pressure that occurs in the artery. It is commonly assessed from brachial sphygmomanometer methods. The mean arterial pressure is an estimate of the average pressure that occurs in the artery and is commonly assessed from the brachial sphygmomanometer methods. The amount of blood ejected by the left ventricle each minute is calculated from which formula? The amount of blood ejected by the left ventricle each minute is calculated from which formula? Heart rate times stroke volume. The cardiac output is the amount of blood ejected by the heart each minute and is about 70 times 70 or 4,900 milliliters per minute. And that's for a male. 3 factors that contribute to arterial blood pressure are cardiac output, blood volume, and resistance. The resistance to the flow of blood, which is related to its viscosity, is a major determinant of pressure. Resistance to the flow of blood, which is related to its viscosity, is a major determinant of pressure. Humans have open blood circular systems. That is false. The blood circulatory system of the human is closed. Blood flows to the veins, capillaries, and without coming in direct contact with tissues and body cavities. Which of the following membrane is responsible for the protection of the heart? It is the pericardium. Pericardium surrounds the heart and protects it. It is composed of tough, dense, inelastic, and irregular connective tissues. ECG records electrical changes in which of the following layers of the heart? ECG is an electrocardiogram which records electrical changes in the myocardium layer of the heart. Body fluid contains ions that produce electrical current and causes changes in the myocardium. Which of the following is the correct pathway for the propagation of the cardiac impulse? Sinoatrial node, atrioventricular node, bundle of his, Purkinje fibers. So SABP, SABP. SA node, AV node, bundle of his, Purkinje fibers. So from the sinoatrial node, So from the sinoatrial node to the atrioventricular node to the bundle of his to the Purkinje fibers. So the thickest layer of the heart is the myocardium. Conduction is known as the pacemaker of the heart. It is the SA node, sinoatrial node. What area of the heart is responsible for the delay of conduction between the atrium and ventricles? What area of the heart is responsible for the delay of conduction between the atrium and ventricles? The atrioventricular node. Bachmann's bundle is located in the left atrium. That is true. The polarization of the heart muscle is when the muscle contracts, and repolarization is when the heart muscle rests. That is true. The sinoatrial node fires at a rate of 60 to 100 beats per minute. The sinoatrial node is located in the left atrium. That is false. It is located in the right atrium, not the left. So what is the correct sequence of electrical conduction of the heart? It goes from the sinoatrial node to the internodal pathways, to the atrioventricular node, to the bundle of his, the right and left bundle branch to Purkinje fibers. The main function of the cardiac conduction pathway is to ensure coordinated muscle contraction in the chambers and effective pumping of blood. The main function of the cardiac conduction pathway is to ensure coordinated muscle contraction in the chambers and effective pumping of blood. The physiologic function of the relatively slow conduction through the atrioventricular node is to allow sufficient time for filling of the ventricles. Physiologic function of the relatively slow conduction through the atrioventricular node is to allow sufficient time for filling of ventricles. The sinoatrial node is the pacemaker of the heart because of natural leakiness to sodium cations. The sinoatrial node is the pacemaker of the heart because of natural leakiness to sodium ions. The initial phase of the action potential associated with the rapid opening of sodium channels is called depolarization. The initial phase of the action potential associated with the rapid opening of sodium channels is called depolarization. When calcium concentrations rises inside the contractile fiber, contraction of muscle occurs. The term that refers to the period when another contraction cannot occur in the muscle is refractory. All of the following are true about repolarization except, so membrane potential returns to resting potential, which is negative 90 millivolts. Repolarization is associated with potassium outflow, so both those statements are true. The one that is not true is it occurs before the plateau phase of the action potential. The long refractory period characteristic of cardiac muscle contributes to all of the following except tetanus, sustained muscle contraction. The long refractory period characteristic of cardiac muscle contributes to all of the following except tetanus. So that's sustained muscle contraction. So long refractory period characteristic of cardiac muscle contributes to allowing cardiac muscle to relax before contracting again. It allows ventricles to fill with blood during relaxation. It promotes effective blood flow to the body. So the long refractory period characteristic of cardiac muscle contributes to allowing cardiac muscle to relax before contracting again. It contributes to allowing ventricles to fill with blood during relaxation, and it contributes to promoting effective blood flow to the body. The normal path of impulse conduction in the heart is the sinoatrial node, AV node, AV bundle branches, Purkinje fibers. So S, sinoatrial node, A, AV node, A, AV bundle, B, bundle branches, P, Purkinje fibers. So the small size of cells in the AV node, the small area of the intercalated disc connecting the cells, the low AP amplitude and the slow rate of rise of the action potential during phase 0 all contribute to the slow impulse conduction velocity through the atrioventricular node. So the small size of the cells in the atrioventricular node, the small area of the intercalated disc connecting the cells, the low action potential amplitude, and the slow rate of rise of the action slow rate of rise of the action potential during phase 0 all contribute to the slow impulse conduction velocity through the atrioventricular node. Also, increased potassium permeability and potassium efflux are responsible for repolarization of myocardial cells during phase 3. During phase 2, the plateau phase, the slow calcium channels have opened and calcium is entering the cell. Calcium entry is balanced by potassium efflux and the membrane potential remains relatively constant. So which phases of myocardial action potential is characterized primarily by calcium entry via voltage-gated L-type calcium channels, and that is phase 2. So which phases of myocardial action potential shown below characterized primarily by calcium entry via voltage-gated regulated L-type calcium channels, that is phase 2. Which of the phases of the myocardial action potential shown below will be characterized by increased potassium permeability, potassium efflux through delayed rectifier potassium channels, that is phase 3. So its action potential conduction velocity is in the atrioventricular node. Which of the phases of the myocardial action potential shown below corresponds to rapid sodium entry, the voltage-gated fast sodium channels, that is phase 0. The rapid upstroke of phase 0 is due to rapid sodium movement down a strong electrochemical gradient following the opening of the fast sodium channels. Which of the phases of the myocardial action potential shown below is associated with the transient outward potassium current? The transient outward movement of potassium coupled with the closure of the fast sodium channels is responsible for the rapid but short-lived repolarization represented by phase 1. Sympathetic stimulation of ventricle myocardium by norepinephrine acting on beta-1 adrenergic receptors would cause an increase in which of the following? Sympathetic stimulation of ventricular myocardium by norepinephrine acting on beta-1 adrenergic receptors would cause an increase in which of the following? So they cause an increase in phosphodiesterase activity, intracellular cyclic AMP, so cyclic adenosine monophosphate concentration, sacroiliacal calcium conduction through L-type calcium channels, and sacroiliacal potassium production through ATP that link the potassium channels. So beta-1 stimulation of the myocardium will cause increased adenocyclase activity, increased cyclic AMP concentration, increased protein kinase A activity, increased membrane calcium conductance, and increased calcium reuptake, all resulting in a stronger but shorter ventricular contraction. So what causes self-excitation, spontaneous generation of action potentials of the synovial node? It is the slow sodium cation influx through non-inactivating sodium channels. Plateau phase of the myocardial action potential is caused by the following ion transport: passive calcium 2+ transport. Plateau phase of myocardial action potential is caused by the following ion transport: passive calcium 2+ ion transport. The autonomic excitation of the heart is contributed to a special type of ion channels found in the membranes of pacemaker cells. The autonomic excitation of the heart is contributed to special types of ion channels found in the membranes of pacemaker cells. So which of the following ions are responsible for the final repolarization phase of myocardial cells? It is potassium cation efflux. The approximate value of the resting potential of the cardiac muscle cells is -90 millivolts. The action potential of the antiarrhythmic pharmaceutical verapamil is related to the blockage of calcium 2+ influx. The action of the antiarrhythmic pharmaceutical verapamil is related to the blockage of calcium 2+ influx. What type of cells are cardiac myocytes? What type of cells are cardiac myocytes? contractile. Self-excitation is the property of electrical conduction system of the heart. Self-excitation is the property of the electrical conduction system of the heart. An individual's number of heartbeats per minute is known as his heart rate, while the volume of blood that's pumped by ventricles with each heartbeat is his stroke volume. An individual's number of heartbeats per minute is known as his heart rate, while the volume of blood that's pumped by his ventricles with each heartbeat is his stroke volume. How is cardiac output calculated? By multiplying the heart rate by the stroke volume. How does your body respond when you need more blood during a period of intense exercise? By increasing your cardiac output. How does one calculate cardiac output? Stroke volume left ventricle times frequency left ventricle. Cardiac output is the volume of blood flowing through the systemic circulation per minute. The amount of ventricles. So, how do you describe best cardiac preload? It's the amount of ventricle stretch at the end of diastole. How do you describe best the term cardiac preload? Is the amount of ventricle stretch at the end of diastole. So cardiac preload is the amount of ventricle stretch at the end of diastole, the filling or relaxation phase of the heart. So the statement that best describes cardiac afterload, it's the pressure the ventricles must work against to open the semilunar valves so blood can be pumped out of the heart. The cardiac afterload is the pressure the ventricles must work against to pump blood out of the heart by opening up the semilunar valves. So it's the pressure the ventricles must overcome to open semilunar valves to push blood out of the heart. What two factors are used to calculate cardiac output is heart rate and stroke volume. Cardiac output is calculated by taking the heart rate and multiplying it by the stroke volume. Cardiac output equals heart rate times stroke volume. A patient with hypovolemic shock is given IV fluids. IV fluids will help increase cardiac output by increasing preload. IV fluids will increase venous return to the heart. This will increase the amount of fluid that will fill the ventricles at the end of diastole, hence increasing preload and increasing cardiac output. Stroke volume is the amount of blood pumped by the left ventricle with each beat. Stroke volume is the amount of blood pumped by the left ventricle with each beat. Stroke volume is the amount of blood pumped by the left ventricle with each beat. Stroke volume plays an important part in cardiac output. Select all the factors below that influence stroke volume: preload, contractility, afterload. Stroke volume plays an important part in cardiac output. Select all the factors that influence stroke volume: preload, contractility, afterload. The answers B, C, and D. Preload, afterload, and contractility all have a role in influencing stroke volume. Which treatments would decrease cardiac preload? Nitroglycerin and furosemide. Nitroglycerin is a vasodilator that will dilate vesicles, which will decrease venous return to the heart. This will decrease preload. Furosemide is a diuretic which will remove excess fluid from the body via the kidneys. So decrease venous return to the heart and decrease preload. An IV fluid bolus and norepinephrine vasoconstrictor will increase venous return to the heart and increase preload. Nitroglycerin is a vasodilator that will dilate vessels, which will decrease venous return to the heart, and this will decrease preload. Furosemide is a diuretic which will remove extra fluid from the body via the kidneys. This will decrease venous return to the heart and decrease preload. An IV fluid bolus and norepinephrine vasoconstrictor will increase venous return to the heart and decrease preload. The patient has a blood pressure of 220 over 140. The physician prescribes a vasodilator. This medication will decrease the patient's blood pressure and decrease cardiac afterload. The patient has a high systemic vascular resistance. The patient has a high systemic vascular resistance, as evidenced by the patient's blood. There is vasoconstriction. This is resulting in a high blood pressure. Therefore, right now, the cardiac afterload is high because the ventricle must overcome this high pressure in order to pump blood out of the heart. If a vasodilator is given, it will decrease the blood pressure, hence the systemic vascular resistance, and this will decrease the cardiac afterload. The amount of the pressure the ventricle must pump against will decrease. Cardiac afterload decrease because the blood pressure will go down, hence the systemic vascular resistance. One more time. The patient has a high systemic vascular resistance as evidenced by the patient's blood. There is vasoconstriction, and this is resulting in the high blood pressure. Therefore, right now, the cardiac output load is high because the ventricle must overcome the high pressure in order to so the patient has high systemic vascular resistance, and this is the patient has high systemic vascular resistance. This is a patient with a blood pressure of 220 over 140. So this is evidenced by the patient's blood pressure. He has vasoconstriction, and this is resulting in the high blood pressure. Therefore, right now, the cardiac output load is high because the ventricle must overcome this high pressure in order to pump blood out of the heart. If a vasodilator is given, it will decrease the blood pressure, hence the systemic vascular resistance. And this will decrease the cardiac afterload. The amount of the pressure the ventricle must pump against will decrease. Cardiac afterload decrease because the blood pressure will go down, hence systemic vascular resistance. What conditions below can result in increased cardiac afterload? So it will be vasoconstriction, aortic stenosis, and pulmonary hypertension. What conditions below can result in an increased cardiac afterload? It will be vasoconstriction, aortic stenosis, and pulmonary hypertension. Vasoconstriction increases systemic vascular resistance, which will increase cardiac afterload. It will increase the pressure the ventricle must pump against to open semilunar valves to get blood out of the heart. Aortic stenosis creates an outflow of blood, obstruction to the ventricle, specifically the left ventricle. This will increase the pressure the ventricle must pump against to get blood out through the aortic valve. Pulmonary hypertension increases pulmonary vascular resistance, which will increase the pressure the right ventricle must overcome to open the pulmonary valve to get blood out of the heart. All of this increases cardiac afterload. Pulmonary and systemic vascular resistance both play a role in influencing cardiac afterload, and this is true. If pulmonary vascular resistance or systemic vascular resistance is high, it will create an increased cardiac afterload. If pulmonary vascular resistance or systemic vascular resistance is low, it will create decreased cardiac afterload. That is the end of this recording. You are very important, especially to us here at the New Chemist podcasting group. You listening in is significant.
Vous êtes très important, surtout pour nous ici au New Chemist Podcasting Group. Votre écoute est significative.
Usted es muy importante, especialmente para nosotros aquí en The New Chemist Podcasting Group. Usted escuchando, es significativo.
Você é muito importante. Especialmente para nós do The New Chemist Podcasting Group. Você ouvindo, é significativo.
Είστε πολύ σημαντικοί, ειδικά για εμάς εδώ στο The New Chemist Podcasting Group. Το να ακούς είναι σημαντικό.
Sie sind sehr wichtig, besonders für uns hier bei The New Chemist Podcasting Group. Es ist wichtig, dass du zuhörst.
Je bent erg belangrijk, vooral voor ons hier bij The New Chemist Podcasting Group. Dat je meeluistert, is veelbetekenend.
You are very important, especially to us here at the New Chemist Podcasting Group. You listening in is significant.